All, this is Dr. Mobeen Sayed from Drbeen.com. Welcome to one more show. Many of you have been asking me to talk about the South African variant and if the UK variant is the same as the South African variant. So I thought I'll pull some data together and we'll share that. I had promised that I'll look into ivermectin, so that is the data I'm still compiling. So I was not at a position to add enough data to be able to present more than what I had already worked on. So within a day or so, I would, as I finish the data on ivermectin, I will present that as well. So having said that, let's start. Hopefully you're all doing good and enjoying your, hopefully, December off. So here on the screen, what we are seeing is this is the normal genome for SARS-CoV-2. And we know this from our previous discussions that it is about 30,000 base pairs, or 29,674 base pairs to be exact. That is the length of the RNA, and one base pair is one nucleotide or one brick in the genome. And we also know from our previous discussion about the UK variant that this part here is the genetic material that makes the spike protein. And here is a rough idea of what is a spike protein. And the genetic genome starts from 21,563rd base pair to 25,384 base pairs. So that is the length of the genetic material that helps the SARS-CoV-2 make its spike protein. The South African variant was reported on 21st December. However, this report that was given on 21st December contained 301 variations of the SARS-CoV-2 that were observed in South Africa since November. So from the start of the November till the 18th of December, South Africa had found 301 variants. So that means this was in South Africa from November till 18th December and not before that, because this variation was not reported before November. And total variation, so keep this in mind so that we can keep ourselves sane as well, that these mutations are a common occurrence. So from South Africa alone, there have been 2,730 variations that are reported. So out of all of those, this is the variation which we're talking about. UK variation is what we're talking about. Denmark variation is what we talked about or will talk about today. So why is this? That is because Denmark variation, we became concerned because it was a jump from mink to humans, and we thought, well, another animal to human jump has occurred and one more pandemic is started. Although one poor outcome, sad outcome, was culling of all of the minks in in Denmark, instead of culling of the minks only in the infected area. And I think some of the ministers had to resign afterwards once they accepted the responsibility that such a large scale culling was not needed. So the variant from South Africa is called 501V2. So we'll talk about 501 mutation in a second, and V2. It started from Nelson Mandela Bay, and then it spread in South Africa, reported on 18th December. So that is some data about it. And then if you look here, the mutations of interest in this one. So there are several mutations. So this is why we are talking about it. One in Denmark, sorry, I did not complete my thought there. One, the Denmark mutation was interesting because we thought it is jump from animal to humans once again. And then UK strain variant or South African variant is interesting because these two variants specifically had more than regular number of mutations that are found. So if a normal viral mutation of SARS-CoV-2 is found to be, let's say, one nucleotide change, in UK we knew that 17 or more changes were there. Similarly, this 501v2 had multiple mutations as well. That is why people became concerned. Now, what are the mutations of interest in this one? One is N501Y. And normally this N in the beginning and Y at the end simply means which amino acid or nucleotide amino acid has changed to what other amino acid. So when there is a genetic mutation, one brick type changes to another brick type. So N is changed to Y, and there is a nomenclature that N stands for what and Y stands for what. We'll see that in a second. And this mutation was at the nucleotide number, amino acid number 501. The other thing that is interesting is that this mutation is in receptor binding motif instead of calling it just receptor binding domain. So if you see here, this diagram, this is a spike protein. In the spike protein, we know that there is S1 part and then there is S2 part. And then we also know that there is a receptor binding domain or RBD of the spike protein, which is used to bind with our ACE2 enzyme, correct? We know this from all along. Now, within the receptor binding domain, there is a specific part which actually connects with the ACE2 enzyme. That part is called receptor binding motif. So the two changes in the South African variant, two of the mutations were found to be in the receptor binding motif. So that means the area that is actually connecting with ACE2 was changed. So these two changes were N501Y and E484K. There was one more change in the receptor binding domain, that means that whole area, and that was K417N. So three mutations in the spike protein receptor binding domain, and then two of those mutations were specifically in the receptor binding motif, the area that connects with the ACE2. So the result was that it has increased the affinity to bind with the ACE2. Affinity to binding with the ACE2 means binding more easily. That means possibly entering more easily in the cells. That means possibly increasing in number more easily, and so on. So it makes it easier for the virus to work with our cells and increase in number. I also wanted to do something before we looked at some of the links that I have collected that you can go over. I wanted to do a comparison of the South African variant, because I see a lot of rumors or thoughts that they are the same one. It was the variant from South Africa that came to UK and changed further possibly, or they both are the same, or it went from UK to South Africa, or so on. So I wanted to compare their important mutations. I wanted to compare them. So here we are comparing South African mutation, which is called 501v2, then UK's mutation, which is called VOC 2020-12-01. Or is it VOC or virus under investigation, VUI 2020-01, 2020-12-01. And then the Denmark's mutation that is called cluster 5. So what they had been doing is they had been looking at the mutations that were occurring in the minks, I believe, or in those areas as clusters. And so this was the 5th cluster. So now let's look at the mutations here. So check this out. N501Y. That is a mutation in the receptor binding motif of the spike protein. It is present in the South African variant. It is also present in the UK variant. That's about it. Then E484K, only present in the South African variant, not in the UK. K417N, only present in the South African and not in UK, not in Denmark. And Denmark variant did not have any of these mutations. Then HV6970 deletion, that is also on spike protein. There is a deletion of 2 amino acids, and that is present in the UK and Denmark variant, but not in South African variant. Similarly, there is a mutation called Y453. That mutation is present in Denmark and not present in South Africa or UK. I692V, same way, Denmark, not in South Africa or UK. M1229I, Denmark, yes, South Africa or UK, no. Then P681H, that is a mutation that is outside of the spike protein, present in the UK, but not in the other one. Why? So the UK has 17 mutations or more. So why have I written P681 here? Because P681H mutation is a mutation in the, actually it is in the spike protein. It is in the furin binding site or furin site. So that actually improves the cleavage of the spike protein and allows it to split faster and then attach to epithelial cells faster. And this is seen in the animal models, not in the human, but still it has supposedly improved the virus's fusion with the epithelial cells. So spread. Interestingly, Denmark's variant has become extinct. So after the lockdown and after the culling of the minks, there were 17 cases in humans as well. But since then, it has been thought that this has gone extinct. It's not present anymore. The South African version has gone to UK, Switzerland, Finland, Japan, Australia, and probably more countries. But the number of arrivals are probably 2 people, 1 person, and so on. It's not a huge, massive spread. UK variant has gone to Denmark, Belgium, Netherlands, Australia, Italy. Today we found that in US as well, and I believe in France as well. There may be more countries too. So that is the change. That is the strain. So what I wanted to do was, what is the basic problem with all of this? Why are people freaking out? So I think there are 2 factors to people becoming, us laymen becoming nervous is just because media is making us nervous. Political actions are making us nervous. And we are thinking, all right, something bad is happening. I think the research workers are becoming nervous because they feel that this might actually escape the immunity and the vaccines might have a problem and the PCR test may have a problem. And because of that, they think this may be a new pandemic. Somebody who's already infected may have the infection again. Although I went out on a limb last time when I talked about the UK variant, and I said that I don't see how these viruses, these variants, can actually escape the already immune person who had developed the infection and recovered, or how would they beat the vaccine? And I had said that monoclonal antibody is possibly beaten if that antibody is targeted at one of these mutation sites, or RT-PCR, one of the channel on RT-PCR in some tests may fail, but the other 2 channels would still work, and so it would still work. And those RT-PCR which are only working with one channel, they are just useless tests anyways. So the only reason that we should think about these variants is that they are causing increased viral load because they are entering the cells faster. That means they are going in and dividing or replicating, increasing in number, coming out, then going to the next cell and binding with it faster as well. So they are increasing the viral load. That means that the shedding of the virus may be increased as well, and the greater volume or greater load that is shed may cause more people to become infected as well, which might mean that the spread in the community may be increased too. What I have not found so far is that virulence, that means it causing symptoms, if the virulence has increased, I've not seen it anywhere so far. And I did the analysis on the death rate in UK, and I was not able to see if there was really an impact on the lethality, if it had become more lethal. In technical terms, a virus that would spread faster can actually be less lethal. This virus does have a window of about mean time of 5.1 days to spread asymptomatically from a person who has become infected. So there may be a different dynamic here, but I doubt that yet. So with this, what I wanted to also then show you is some sites here. So this one, this is Drbeen. So this is one site. All the links are in the description. This one site is about the questions about South African version. So they have answered a majority of the questions. Just a heads up that majority of the questions are answered by saying, we do not have enough data, we do not know enough, so we will let you know once we know more. And I am seeing WHO saying the same things. I'm seeing the government saying the same things. I'm seeing politicians, even research workers. I would show you some more comments from various professors of immunology or virology and so on. And they just keep saying, we do not know. So honestly, there is a lot of noise at this time, concern, reaction, the countries closing down and the lockdowns happening and all that. Maybe it is happening for the right reasons. I do not know yet. This is the same thing as when the SARS-CoV-2 started in December, January timeframe. And many people thought this is not a big deal. And they thought just one or two cases, so what? So maybe I'm being naive here. But at least from the technical structures, I don't feel that we are in a bad shape. But as the data evolves, we'll know. So most of the answers here are going to be in similar vein, that we don't know yet, we are still figuring it out. But there is a decent set of questions at least that you can look at. Then this is another interesting one. Here what they have done is, what are experts saying? And in the majority of the cases, you would see that the experts would say, we don't know yet. And so they have a number of people, for example, Professor Jonathan Ball, and I'm not picking him because I want to pick on him. I just stopped here. The mutation that has cropped in Africa has been seen before, and we have no idea where it impacts on virus transmissibility or immunity. We need to study the impact of mutations on virus behavior. But until we have performed those important experiments, we should avoid panicking. If we practice social distancing and limit our interaction with others, then we will avoid spreading the virus, no matter what collection of mutation it has. So sort of, we don't know, but we are also here, be careful. So that's fine. So most of these answers you would see would be in the same vein. Then this is an interesting presentation. I just wanted to quickly go over this. This is a presentation by Saleem S. Abdul Karim, FRS. And I think this is from South Africa. And here he is a professor of global health, Columbia University. So that is here. Co-chair Ministry of Advisory Committee on COVID-19, member African Task Force for Coronavirus. So if you very quickly look at it, what they're trying to understand, and again, at the end of the day, they would say transmissibility is more, it is probably spreading faster, but we do not know about all the other questions that I said in the beginning, that will it cause any issue with the vaccine, or would this cause more reinfections, or would it cause a failure of the monoclonal antibodies or polyclonal antibodies or vaccines? So all of that is up in the air. But here, what they're trying to say is, here is the second wave starting because of this new variant. And they are saying that this wave, so if you look at the right side of the chart where it says new cases, they're saying this wave is going up faster. And I really, since somebody told me, some of the folks here made comments that South Africa has banned ivermectin, which really, if that has happened, that is one of the most bizarre thing I've heard. Yes, in the US here, we cannot give ivermectin, or pharmacy can decline it, but altogether banning ivermectin was just, it's still beyond me. So here are the cases. Maybe just start using ivermectin and you'll see a better outcome. So then here is the confirmed cases by province, then cases by confirmed SARS-CoV-2 cases by province again, 7 days moving average. Here, comparison of SARS-CoV-2 cases in first and second wave in Western Cape. So what they're trying to say is that if you see here, this is the second wave and the number of cases are a lot. And this is the first wave. So they're thinking that it is spreading faster. And of course, that means it is causing more cases. Comparison of SARS-CoV-2 cases in first and second wave. So here is a comparison. And the second wave is still evolving. So that line is here. Expected and actual all-cause death. So this is all-cause death, not COVID-19 death. All-cause death during COVID-19. So here, predicted deaths, and this is recorded death. So we'll see as there are more cases, that will the death rate equally go up as was the previous variant, or is this variant causing more deaths? Still, it's not known. So the fine balance between virus and host, here what they're trying to say is that mostly the virus actually tries to live in the host more successfully. So it tries to learn how not to kind of bother them too much. So some more RBD mutation. RBD, receptor binding domain mutations, have been a lot. So it's not just this one mutation. Then this is an interesting one out of all of these. Speculate the following. So this is their speculations. Number one, higher viral load in swabs may translate to higher efficiency of transmission, that is higher transmissibility. I don't know, higher viral load in swab may translate into that. I think the sentence could be restructured. What he's saying is that if we are seeing that people have a higher viral load in swabs, that means the throat has more virus, and that means when they're talking and laughing and sneezing and coughing, they may be transmitting more virus volume amount, and that may cause more spread. This may translate into a higher R naught. Again, these are speculations. We do not have the proof yet. While other viruses are transmitting, this variant is transmitting faster. This may translate into a second wave that will have many more cases than the first wave. And then what do we know and what do we not know? I think you can guess that what they're going to say is that this this mutation causes more transmission, but we do not know if the vaccines would work or not work or immune. So this is what is the presentation. The link is in the description as well. So please see it if you feel. Here is a quick article about 501v2 variant from South Africa and some more data here. This is the variant from UK, and it is interesting that if you look at cluster 5 variant, this is mink variant, and if you see down here, a couple of things that were interesting for me. Number one, political consequences. It was revealed in late November that the Minister for Agriculture, Mogens Jensen, if I can pronounce the name correctly, and 5 other ministers had been made aware in September that the culling of the entire country's mink population, rather than just those in the infected area, would be illegal. Facing calls for resignation from the parliamentary opposition and sharp public criticism, Prime Minister Frederiksen acknowledged that the order to cull all minks was illegal, and Jensen resigned on November 18th. A deal was later reached to retroactively make the government order legal. So one, the responsible people resigned, and secondly, they did make it legal as well. And then this was interesting for me as well, that international reaction on 6th November, UK announced that Denmark would be removed from the corridor white list of the countries from which travelers may return. without self-isolation for 14 days, citing the cluster 5 variant. On 7 November, the UK announced that it will also prohibit entry by non-resident travelings from Denmark and non-residents who had been to Denmark within the past 14 days. British citizens will still be allowed to return home, but they, as well as other members of their household, must self-isolate for 14 days. This travel ban was to be reviewed after a week. So UK, it was interesting for me that UK kind of banned it. Not a bad thing, but at the same time, then UK is now going through the similar issue, rather more intense variation. Then this is base pair. So when we talk about the SARS-CoV-2 genome and we say it is about 30,000 kilo base pairs, what is a base pair and how do we measure them? So just an article for your interest. This was always an interesting article. This is a UK variant, and I love this sites. So this is virological.org. Their list of variations, all of them, and then what do they mean? So it is an interesting read. This is interesting. This is GISAid. I think this is called Global. This is short for Global Initiative for Sharing Avian Flu Information. So that was for flu. So this company or this organization, it's a nonprofit. It was formed to share more information about avian flu, but they have also been sharing information about coronavirus. So this is the 501v2 variant from South Africa. And if you see here, this is the spike protein, S1 and S2 parts. And if you see this part here, this area is the receptor binding domain. And then there are mutations that you can see, E484K and then N501Y. These mutations are in the receptor binding motif. This is the area which is connecting with the green thing, which is the ACE2 enzyme of our cells. And then here, K417N, this is another mutation, but it does not directly connect with the ACE2. And I also wanted to quickly share how they name them. For example, if you see here, the name N501Y means a change in SPAR gene, which is an amino acid, and it is abbreviated as N, to tyrosine, which is another amino acid, which is abbreviated as Y, in amino acid position 501. So you would read this as the asparagine changed to tyrosine at the 501 amino acid position. And so all of these things have similar nomenclature. And finally, this is a quick article about what is GISAid and what is their function. So this is the talk for today. I'm just going to quickly look at some of the comments, and then we will. I'm collecting the data for ivermectin, so I would talk about it tomorrow. My request to you is please like, subscribe, and share if you like what you're seeing. And thank you very much for all the coffees. So if you wanted to buy me a coffee, there is a link in the description. If you wanted to just support the channel, there is another link in the description as well. And let's see a couple of questions here. Margaret, thank you very much. And Margaret, thank you very much for your generous support throughout, including this month and all the previous months. So thank you very much, Margaret. Wayne has a question. A YouTube doctor agrees with IMath protocol, but also suggests selenium and B complex. I did research on selenium and purchased some at Walmart today. What do you think of selenium? So Wayne, I have talked about it. I think it's a good thing to use at this time. So if you look at my videos previously, there is a video on selenium as well. I had also done a video about math plus protocol by Dr. Paul Marek, and I had added some more things to that as well. Arun has a question. Why so many people are dying in USA due to cold, and why UK variant is not UK? Arun, why so many people are dying in USA due to... No, it's just the virus itself. And then, of course, there is cold and flu season as well. And it's just that too many infections are out there. So number of cases are increased, Arun. So when the base number of cases are more, then of course there is a percentage of deaths that would occur as well. And then why UK variant is not UK? I don't catch this part of the question. UK variant, ideally, look, when Wuhan was the source of the infection, at that time there was a lot of um, noise that don't call it Wuhan virus. And so there was one name that was SARS-CoV something, and then finally the name SARS-CoV-2. And Wuhan, or the place name, was removed so that people are not, they don't feel taboo that the infection is with their name. So we should not name variants like this, UK variant. So now why shouldn't UK say that, hey, don't put a name on the variant? But it is interesting that when it was Wuhan, then the whole world was saying don't do it. And again, I'm not proponent of saying we should call it Wuhan virus. What I'm saying is we should be consistent in attributing the virus. Either stay technical everywhere or don't stay technical everywhere, but don't be picky and choosy. But Arun, I still don't get the second part of your question. Guy Telfer has a question. How about severe cases and mild in new variant or hospitalization? No data for US. Any new information about vaccine treatment trials? So no data in US for the variant yet, and no data from the countries for the variant and variant related cases and deaths. And of course, there is a lot more about vaccines. So in the next 2 days, I'll talk about ivermectin and the vaccine update as well. And thank you very much for the super chat. Barbara Warren, thank you. Super sticker as well, and the super chat as well. Patrick, that is correct. Human behavior is USA's problems. Yeah, that is correct. Saeed, I have Hushiyar. I have actually talked about favipiravir as well. So please look at my video. I think it is quite a decent solution. And so look at that as well. So Carlos, this is an interesting question. For how long can ivermectin prophylaxis be taken? What do you recommend? What dose do you recommend? So the thing is this, ivermectin has never been used as this is an off-label use. It has never been used as prophylaxis before. It was used for deworming, and normally once in 3 months or 6 months or a year. My patients, so again, this is not a prescription for anyone, but my patients who are on prophylaxis, I usually give them 1 tablet, 6 milligram at least, or 2, depending upon their body weight, once in a week. And then if they're sick, I give it to them for 4 or 5 days continuously. Now, what I do not know is if it is more or it is less, but so far I have not seen any side effects of it. John Snyder, thank you very much for the super chat and the sticker. There's a question from Charles. Question, why would South Africa ban ivermectin? Any valid reason? I have no idea, Charles. This beats me as well, that why would they just ban it? So Steve says that Campbell has just done a talk about it. So I'll collect some data as well, and we'll talk more about that too. So Sasha says, why is the new variant supposed to be more dangerous to younger people than the previous version? Very, very good question. Look, remember one of the reasons, so I've talked about children and their protection from this virus many times. And main reasons, number one, they have less ACE2 receptors or enzymes on their cells. Number two, they have better cross-reactivity and cross-immunity. Number three, they have better NK cells. Now, because they have less ACE2, SARS-CoV-2 original variants were not able to enter their cells that easily. So most of the time, it was just mild or asymptomatic situation. Now the new virus is supposedly able to bind with the ACE2 with higher affinity, so it has a chance. Imagine that there is a fish that is going fast and you're trying to grab it. So the virus is just going fast, and now it can grab the cell very easily. So it is possible that it infects more cells. I would still bank for children, I would still bank on the presence of more NK cells, the presence of cross reactivity, the presence of trained immunity on the innate arm of the system. So I think that the children would still be better protected than adults. It's just that they may have more infection, which means they can become more spreaders as well. But still, I have to look at the data, but this is the basic reason. As son, it is very easy. So number one, I have a playlist called all COVID-19 videos on my channel. So if you go in my playlist, you would find that. And I have one more playlist which says all COVID-19 QA, or your questions answered, and all the Friday QAs are in one list. Now, when you open a playlist, then YouTube gives you an option to search within the playlist. So you can write, for example, Favipiravir, and it would come back with the lists. Okay, so Wayne says, my bad, South African IVM story. The country was banning animal IVM, not human IVM. Very interesting. So maybe they are banning that so that people don't take it. Suzanne says, virus in USA first, which gave the heart symptoms first. My experience as my friend in hospital and then caught it. Are you talking about the new variants giving heart symptoms? So Nabu says, what is the difference between RBD and RBM? So let me quickly explain it once more. Look, let's say here is the spike protein, and spike protein is made up of S1 unit and S2 unit, right? So let's say these are the two units, S1 and S2. I'm just making up a design. Then on top of them is the receptor binding domain, RBD, correct? This is RBD. This binds with the ACE2 enzyme. This is ACE2. This is our cell, correct? Now that part of the RBD that actually connects with the ACE2. So out of this red block, not every protein here connects with the ACE2. Instead, this area connects with the ACE2. So that area that connects with the ACE2 enzyme, that area specifically is called receptor binding motif, RBM. So whenever there is a mutation of receptor binding motif, that actually means a mutation in the receptor binding domain, because that is the bigger chunk of the spike protein, and within that the connecting parts to ACE2 are called receptor binding motifs. I hope that clears that. Shahida has a comment, wish somebody could find out the difference in response to new strains of viruses by people who became immune naturally versus those by vaccination. I think that data would evolve soon. Stuka says, what is the difference between COVID-19 and COVID21? I did not know that we have a COVID-21 as well. Do we? COVID-21 lethal virus. That is a film. Album by Rashida. So this seems to be a film. Good. I did not know the answer to this one. You win, Stuka. Yahya says, what do you think, Dr. Bean, about COVID-19 and the government? Government and politicians are just all over the place. Very, very few governments did the right thing. Majority did the wrong thing, or instead of calling it wrong, just incompetent things. I think more than the government, medical leadership's responsibility was to provide information for how to do the right thing. I think that is where the actual problem has been. Yes, you can say that in the US, it is possible that somebody who comes up and says, hey, this is the right thing to do, and then government doesn't help with that, that can be a problem. But I have not yet seen medical leadership coming up with something right. And that, by that, I don't mean Dr. Paul Marix and Dr. Corey, they are doing something right. I'm talking about those who are sitting in the decision-making chairs. They are not making the right decisions. So, Gaurav, this is a good question. Can a person who's already had COVID-19 6 months back be reinfected by a new COVID UK strain or South African strain or variants? I kept calling it strain as well, but then I stood corrected. This is still being seen. In my opinion, no. But we'll see from the data. And I'll tell you why no. I explained it with the UK variant discussion. The reason I call no on this one is the following. Look, when you become infected to the natural wild virus, so let's say this is the virus and it has spike proteins on it, and if you have successfully recovered, that means your body has made thousands of antibodies to various epitopes present on this virus. And we know that there are thousands of amino acids, and every 6 to 7 amino acids can make one epitope that can be targeted by an antibody. So antibodies, tons of types of antibodies are generated to fight against this virus in the future. Now imagine that there is a change. In the bigger picture, yes, there is a change that is increasing the transmissibility and affinity of the virus. But in terms of the antibodies, there is a change here. Let's say a small change here, and these are just 2 amino acids that changed out of hundreds and thousands of them. Now, maybe this antibody that binds here might not be able to bind that successfully, but what about all the other antibodies that are binding to the other parts of the virus, including the spike protein? So let's say there are 200 antibodies that can bind to spike protein and one fails. Then what? You should not get reinfected by this one. So you will get reinfected if all of your antibodies have failed, or if the virus has changed its spike protein in a way, let's say it has made the shape of the spike protein like this now. So all those antibodies that were against the spike protein, they have all failed. And now the virus can still connect with the ACE2, but the spike protein shape is totally different. Now it has escaped immunity, and now there is a new pandemic. But that kind of change is not been seen. So there is a question, existence.com, which is more effective, ivermectin or Regeneron and Lilly monoclonal antibodies? So monoclonal antibodies, we still do not know enough of their use, but I would think that they are good if they are targeting and neutralizing the virus. Regeneron, I really like it because it is more than one antibody cocktail, so it has shown very good effect as well. And please remember, Regeneron can be taken in the hospital if you ask for it. So if somebody has somebody in the hospital, please advise them to say, can we have Regeneron? And ivermectin is just, it's a superhero. So if I had to say which one is better, I think ivermectin should always be there. And then if somebody is sick, Regeneron is second important thing. But if there is no ivermectin, then more people are going to need Regeneron because they're going to become more sick. Monoclonal antibodies, I'm still sort of not too convinced yet, but they are good. Ideally, they should neutralize. Gold Country Russ says, Dr. Bean, can we have a petition to the NIH to authorize use of ivermectin? The cool beans will respond. Okay, I will work on that. Cool. So so Flower, I had gone in and figured out how to unblock and then unblocked you. So sorry that day I blocked you and you told me that it was not, you were just responding to them. So I found out a way to unblock. So Ruby's Red says, question, monoclonal antibody treatment appears to be accelerating mutation and genetic drift in the virus. Your thoughts? So it's very simple. Actually, presence of the virus in us and for it to try to live in us is called the selection pressure on it. So let's say this is the virus's spike protein. This is the domain, receptor binding domain. This is the S1 unit, S2 unit, and so on. The virus has to figure out a way to live in us more permanently. We are trying to figure out a way to kill it. So virus has a pressure to evade our situation, our attack on it. So for that, just randomly, when various variants are made, those variants, there may be some variant that can escape our attack, and that variant may live on. So whenever you will try to treat the virus either by external antibodies or by internal antibodies or attacks on it, that is actually taken as a selection pressure. That is taken as a challenge to the virus to say, okay, can I now have mutations that would escape this and I still continue to spread? So of course, as we put pressure on the virus, now vaccines would put more pressure on it as well. And of course, new variants would come up. So Zunar says, have you looked into hesperidin? No, I have not. Showed high affinity to dock with the virus in early computer models. No, I have not. I would love to see it. Cool. So I think Flower says, it was so appreciated, Dr. Bean. Thanks again. It was no problem. I know how it works. I'm a YouTube moderator in a few places myself. Thank you very much. And sorry for the incorrect block. Cool. So should we stop here for today? I'll try to do this that tomorrow we talk about either ivermectin or more data on vaccinations, or as the days evolve, maybe talk about data in UK for deaths and other. So we'll do that. Once again, thank you very much for your time. Please like, subscribe, and share. And if you like, you can buy me coffees or you can support the channel. Links are in the description. Thank you very much, and I'll see you tomorrow.